shortly at the end of our presentation. I don't want to go too much about, all the details, but let's talk about routing profiles in general. They are inherited from the process level to the neighbor or to the peer group, if you do BGP, or to the neighbor if you do OSPF. And then from there, they are inherited to individual peer or individual neighbor, right? They are global at the address family also, so you can decouple all of that at any point in time. That is the flexibility that you have. You want to create a peer group, which is a little bit different than what Cisco defined as a peer group. For us, a peer group is an administrative entity that is managed by the same sets of rules, but at any point in time, you can decouple a peer from that peer group and apply to him specific sets of rules just for that peer. Why are we doing this? Is because we realize that as a firewall, quite often, people like to do it more from the administrative perspective rather than from the pure network perspective. And that's why we have this a little bit of a distinctions. So LR and VR, to answer Daniel's question, LR and VR are, if you want, the same, will appear same, identically in the same function, but the implementation, that's why I went over in the first slides, is totally different. The implementation behind it's totally different, right? So we went over the filters, and once again, very quickly, they can be reused between multiple LRs. You can even reuse them between multiple VSys. So really define one, use multiple. You create a filter profile. You want to filter everything that is RFC 19 and 14 from any advertisement because you don't want to deal with that. Create it and then reuse it. And you can reuse it as many times as you want. So very efficient way of doing. And of course, we offer you scalability here. Access lists, these are system, this is from the routing engine perspective. It's not this, you may have limitations on lower end platform, but what I'm, and that is probably something you will have to, look into the data sheet of the specific platform. But technically, from the software standpoint, this is what we can do. We can do 248 access lists with 4K entry each, whether it's an access list or a prefix list. And we can do a route map up to 4K as well, whether it's a redistribution route map or a filter route map. It's 4K, and each route map can have 4K entries. So this is a lot of route map. You can have a total of 8K route map. So 4K redistribution, 4K BGP on a single system. So there's a lot of scalability here as well. Regular expressions. So I realized when I was, doing my my initial work that the regular expression engine on the legacy routing engine was sometimes not perfect. There were some exceptions. This is now fully standard regular expression engine. Whatever you use will be supported. I put even the links. I use that as a point of reference, regex 101, to do all of your regular expression, whether you apply for an AS path, for a community, a large or an extended community. You use regular expression there, not a problem. Regular community does not use regular expression, but we have make your life simple. We associate the common name to each of the numbers. So for example, if you do internet or do not no advertise, we will show you no advertise, and you don't have to type or remember the number. Filter, so don't forget, this is like a Cisco or a Juniper or an Arista. Access lists are an ordered list of rule processed sequentially from the top to the bottom, right? They are, of course, because they are using for routing, they are source only. Well, no, actually, no. They can be what Cisco call extended access list with source and destination. And we do it for multicast. If you want to do a filter access list for multicast, and you want to filter the source and the group, you will use an access list, and we only support access list. That way, the source will be the source, and the destination will be the group. But it's not used for for policy-based forwarding, for example, or policy-based routing, which we do not support yet. Those access lists are control plane access lists. Of course, it's processing stops on the first match, implicit deny any at the end, right? You can do it for v4, v6, and v4 extended for v4 only, because we do not support multicast v6 yet. It will be for multicast for v6 when we support IPv6 multicast, which is an upcoming in the next release. We will have IPv6 multicast support. Prefix lists, that is for unicast only, so we do not allow you to filter multicast using extended prefix lists. You can only use, and there you have variable mask. Like access lists, they are ordered lists processed sequentially from top to bottom with an implicit deny any at the end. So we support two operators, maximum greater than or equal to, and less than or equal to. Those are the two operators. So if you want to do an exact match, you have to put the same length of the mask with the greater than and the less than, and that you have an exact match. Okay. V4 and V6 and unicast only. And then, of course, ASPAF lists. ASPAF, we do support regular expressions, as you can see in the example here. 64 rule per ASPAF, that's the maximum, with an implicit permit at the end. So that's also standard compared to Cisco and Arista and Juniper. And we support the standard regular expressions on that. One recommendation when you do lists, ordered lists, just like a Cisco and Arista, put some space in between. We do not do dynamic reordering of your list. So the sequence number here, I usually put 10 in between in order, if I have to insert, because it's top-down evaluation, if I have to insert one sequence, I have some space to do it. Don't put 1, 2, 3, 4, because then you have to reorder it and first remove it and then reorder it, so which take more time. Community list, like I said, we do 16 maximum in a list for the regular, and they are predefined, so with the custom value, so that way you simplify your life. These are probably the one you use the most. Large and extended, if you want to do that, we support 8 for those, and of course we support regular expression, standard regular expression. Finally, we're going to talk about roadmap. And here is very important. Roadmap, there are two kinds of roadmap, one for BGP redistribution, one for BGP neighbor, and one for protocol redistribution. In this case, we see a filter, a roadmap filter, which are essentially a conditional advertisement, right? So you need to match a specified sets of criteria in order to set another sets of criteria. In the BGP mode, we match and we set dedicated criteria for BGP, right? So here you see all of what I explained is there. You have the full knobs of BGP at your disposal with the advanced routing engine. I want to put it like this. It's a little bit bold, but this is true. Look at it. You have a match. You can match on pretty much any of the discriminant of BGP or any of its attribute. And we support tagging on all of our routing protocol, whether you do a static route, an OSPF route, a RIP route, a BGP route, tagging is there. So it's easier for you to, if you want to tag and identify a route through tagging, it's easy. You want to do it through community, which I recommend, it's easy. We support all of them. You want to do it per source of the prefix, use an access list or a prefix list. You can choose. They are mutually exclusive. We can do ASPath exclude. We can do ASPath prepend. We can remove part of the path. Whatever you can do. BGP has like all those buttons that you can set and play with. We do support the weight, that is Cisco feature non-transitive attribute of BGP that is dedicated for Cisco, but we do support it because we realized that Arista and Juniper also supports it, so we added that. Of course, the origin you can set, whether it's IGP or unknown, you can set it there. Once again, a lot of, you see how busy the panel is for a roadmap, a match and a set. Once again, you have an implicit deny rule at the end, and you can reuse them. So, if you feel unease to configure a roadmap, and that is pretty normal, you may have someone helping you, and then you have fine-tuned it to a degree that is exactly the filter that you want to do, and then recycle it. That's not a problem. You can do it at the peer group level between LR even, so that's better. So for route distribution here, we are leveraging the power of our UI. By selecting, when you select the source and destination protocol, the UI will only highlight the items that are relevant to the functions you want to do. For example, in this case, the source is OSPv3, so IPv4 is gone. We do not support multiple NLRI today with OSPv3. So here you match OSPF criteria that are specific for v6, whether it's a prefix list or an access list. And then the metric, the interface, the tag. That's pretty much what we support. But when you set as BGP, then the UI will propose you everything you want. It will preset, for example, the origin to IGP. If you want, you can set your local preference. You want to tag it, tag it. I always recommend tag your routes. It's always important. When you redistribute or filter, always tag, so you know what you're doing. Setting the weight if you want, or community, you name it. We added this feature that is not existing before. This is especially for our lower hand platform. In lower hand platform, due to the minimum amount of FIB that we have, they cannot participate easily in large OSPF area or BGP domain. In this case, we set in place what we call the RIB filtering. The RIB filtering allow you to define through a route map a filter between the RIB and the FIB. It's on a per protocol basis, so you define it. As you can see here, I take the initial slide. You define it here between the RIB, the original RIB, the central RIB, sorry, and all of the local RIB of all the daemon, but you apply it here. And what you do with that, you create a route map, and you basically aggregate all your prefixes, so you guarantee that they will fit into the FIB memory, which is limited in a sense and cannot be shared. So that is a way to preserve the space into the FIB. The RIB filtering does not preserve the space in your RIB, but the RIB is in main memory, and we do not impose a limitation there. You can go full routing table if you want. I do not recommend it, especially on the lower end platform, but you can take more in the RIB than the FIB allow you to. For example, most of our Gen 3 platform will have a FIB capacity of 100,000 routes, most of them. Some of them lower, but you can go beyond in the RIB and then apply the RIB filter so that you're sure that anything you're pushing down to the FIB is below 100,000. So a very useful feature to allow a lower hand device to participate into a large OSPF area. And before, a lot of our customers had to create like a totally stubby area, for example, for OSPF, and then they had some redistribution there, and then it's a not so stubby area, and they have to handle all of the LSA differently and manage the type 5, the type 7. They didn't like it, so now, hey, you don't need to put it into your area. If you do redistribution from another protocol, do it with an SSA if you want to, but you have more flexibility here. And this is an example of the RIP filtering. You see, once again, it's a route map. I call it only 10K routes from BGP. And I match a specific amount of prefixes. And what I can do, I can just say, hey, I just want this next hop, and that's it. Right. So I'm not going to go over this. This is for your reference. But troubleshooting, and I'm going to end my presentation with that. If you want to troubleshoot, or even just look at your routing status, you do show routing route, right? That's the first command I actually typed on the firewall when I joined Palo Network. Now it will come back and say command deprecated in advanced routing mode. Once you have migrated your firewall to the advanced routing engine, the old commands are not there. So this is important. We provide you, as I mentioned earlier, a migration path from the legacy to the advanced, but we ask you to save your legacy routing engine configuration. If you wanted to go back to your legacy routing engine for whatever reason, the last saved configuration, it's still there. It's no longer used. And that will become active at that point. Okay. So that is something that you have to keep in mind. We have a CLI command that wipe it out if you don't want it. And probably in the future, we will tell you that at a certain point that we need to wipe it out. But that still to this day, because we are still asking you or inviting you to migrate to the advancing routing engine as much as you can. And I just show you, the advantage of it. If you want to backtrack, no problem. You just wanted to try it. It doesn't match what you wanted to do, or it's too complex. Then go back. You will be returned to your last saved configuration. The new command, however, is show advanced routing. And then here, the commands are split into two. Highlighted in red, you see whatever is specific to a routing protocol. And highlighted in blue is the generic platform-specific information. Whether you want to see your FIB, you want to see your interface status, you want to see a monitoring parameter, all of that would be more specific. In red is OSPF, multicast, BGP. We do support the debug, where you can see the status change. For example, you will see the open message of BGP, and the exchange, the negotiation during the open message of its capabilities. We support way more capabilities, of course, with the advanced routing engine. We negotiate, for example, 4-byte ASN from the get-go. It's no longer a need to be renegotiated. It's there, of course. And of course, here, once again, you have it in two. You have per protocol and also per platform specific feature. And finally, something that I really like that the engineering team has done, which is the capability at the CLI to do a pickup on a per protocol basis. I'm an old guy. I like the truth is in the sniffer trace. That's what I keep saying. Debug, routing, pickup. You can do it per protocol. You can do it per protocol and per LR as well. So to limit the amount of data you're going to get, you have a problem establishing a BGP neighbor, launch pcap capture, and you will see where the problem relies. OSPF, maybe the metric or the type of interface is not matching. One is point-to-point, one is broadcast, and then they don't necessarily establish a neighborship. Then you can see that in the pcap as well. So in conclusion, a new routing engine, everything is profile based. You can go from very simple with an access list, for example, for filtering, and we do support super conditional advertisement with existing map, non-existing map, advertised map, suppressed map, and suppressed map. You have the full knobs of the Jumbo Jet at your disposal for the advanced routing engine. Everything is usually hiding behind the advanced button if you want to, but if you want to do something simple, it remains simple. If you want to do something complex, you have all the buttons there. Now, if I have a little bit of time, I don't know how am I doing with time. I can can show a bit of one firewall if I have
you've definitely got a few more minutes, Patrick. That's fine. There was one question that did come up in the chat. What's the main difference between a logical router versus a virtual router? And we could associate a logical router into a virtual router was the question, or what is the difference there?
All right. So from the functional standpoint, they are identical, but the implementation behind it is totally different. Let's put it this way. One leverage the network namespace in order to provide the separations of logical router, and then the other one is basically another instance of the same process. So we have more isolation more security, in fact, between LR than we had with VR. I hope that didn't answer the question to Adrian. Now, very quickly then, you see here, I have a Gen 3. I have selected the advanced routing engine, and I wanted to show you a little bit how to migrate this one from the legacy routing engine to the advanced routing engine. So I'm going to do something that you should not be doing, so don't look at me. It's going to reboot the AI, but we're going to say yes. Okay. So let's wait. Normally the UI will disappear. Don't do this. It's not supported what I'm doing, but just to show you to go back to fake going back to the legacy routing engine, and then the migration process. And yeah, okay, so to come back.
So there was a couple of other questions of like, why did you change the name from LR to VR? My guess is to differentiate the two.
Yes,
from the
so that's a good question. It's a good question. It's because Panorama, of course. In Panorama, you need, because it's two different routing engine, your traditional template and template stack will not work on the new advanced routing engine, right? So that's why now you have LR and VR. What we recommend is when you migrate, put your migrated device into a new device group. And within that device group, you can apply your template and template stack that are specific. Panorama will not translate that from the legacy routing engine to the advanced routing engine. So Panorama will apply specific to the advanced routing engine to legacy routing engine. The Strata Cloud Manager does the translation for you. That's the main difference. But if you use Panorama, then you have to segregate your advanced routing engine migrated device from your legacy routing engine device. Okay, so now I'm going to pretend that I am in legacy routing mode. I did this little trick so don't do that at home. But now what I'm going to do is I'm going to click here, advanced, to enable the advanced routing engine. And then here it is. So it will propose you this. It offers you two choice: either I made a mistake, cancel, or yes, I want to continue. And then I'm going to go through the migration process, or skip. And if I click skip at this point in time, the system will reboot after I commit, and the configuration will be totally empty. So you lost everything. Don't forget, your existing configuration for the legacy routing engine is still there, but it's no longer used. So if I click yes, okay, let's say yes, I want to do. So then we propose you the color code. Like I mentioned earlier, green, okay. Yellow, you have to look at it. And orange, we no longer support the feature. I hope you didn't do that. And then red, cold attack. That's basically in brief. So let's do that. Let's see. What did I do? Okay, so I have one yellow here. When I migrate one LR, one VR to an LR. Okay, so I say, okay. What did I do wrong, right? So I want to know what is going on. It will give me immediately another help on the side in order to assist me with my configuration. But if I click continue,
just so you know, we're not
the
seeing
migration
the
complete, etc., etc. We have to do the commit and the reboot in order for it to be active. It's important that you reboot after the commit, because otherwise you are in between state. So don't do that. So what is important to do at this point in time is just exactly that, commit and reboot your configuration. You can say no, and then if you say no, the configuration is automatically reverted back to the original. So we put some safeguards. So if you're not happy with the way the configuration was done, you can do that at any point in time. So let's try it again and say yes here, right? And we say okay here. Right? I want to see exactly what happened, and it will show me the configuration here. So why is it yellow? It's telling me here, virtual router dampening profile are incompatible with logical router dampening profile. And it's correct. That's one of this awkwardness that we saw, that I saw when I did this exercise of the advanced routing engine. I had cutoff reuse, decay half time, I don't know what it was, reachable, and decay half-life unreachable. It's a little bit, yeah, it's functional and it works pretty well. It's also very detailed, but unfortunately, that's not what the industry is doing, right? And we don't have that anymore. I'm going to show you in a second what we do have. So it's going to say, look, this is what you put as the default for the legacy routing engine. We have another set of default now. Make sure that it match what you were doing, and because we cannot have a one-to-one translation between the two. So you say, okay, so now I have, and I can see my new routing profile and all of that. And I'm going to say close here, and I'm going to say continue, and then I'm going to say yes here. And then, once again, I have to reboot, commit and reboot. And I say continue here. And, because once again, you shouldn't do that. I do how the migration process work, but you should always, when you do change, commit and reboot. And I didn't do the commit nor the reboot. So just the UI is changing at this point. It changed the templates to logical router. So while it's doing that, I was wondering, yeah, there is another question. In a multi-VSys environment, is recommended to implement LR? It doesn't matter. You can do either. We do not do anything for in a multi-VSys environment. We do not support the advanced routing engine is, however, global. You cannot do it on a per VSys basis. So which means that once you have migrated, you have to migrate all of your VSys to the advanced routing engine, right? It's not per VSys basis. You cannot have one VSys in legacy mode and one VSys in advanced mode. Then here you see the UI completely changed. I have logical router, and then you see all my profiles here, right? So I was mentioning that an dampening profile for BGP that was not translated perfectly. Let's see what it is for BGP. So let's go to, it's a BGP specific attribute. So let's go there, and here's my dampening profile, and I can, and oh, this is totally different now, right? Then have the cutoff, the half decay advertised, half decay non-advertised. You have things that is supported by Cisco, NRStar, and Juniper, suppress time, reuse limit, half-life, and maximum suppress time. These are the standard dampening profile. Once I define this, you see that they appear into a list of profile, an ordered list of profile. You can at any point in time call them into the logical router. So here in the logical router, as you can see, I have only one. It's the default that I have created. I call it default, but normally it's not created. So you have to put your interface into it. And then whatever you want to do with BGP, you will have to do it here. Once again, if you look at the peer group here, let's add the peer group. you see here's where your profile is going to be called, whether it's an authentication profile, a timer profile, or a dampening profile, will be applied to that specific peer group. And then here you see the IPv4 address family. That's another profile. You have to call another profile. So for example, I have a default, and we always provide you the default value, which is the industry default, the one that you will find by default on a Cisco or a Juniper or an Arista. If you want to do v6, and you can add the peer group, define a filtering profile de facto. No, let's say that I want to choose the default timer profile, and I want to choose a specific dampening profile here. Now I want to add to this peer group, I want to add a peer, right? And here, let's say I want to put an interface. Well, I didn't define the interface, so that's not going to work. But once again, you see the advanced button is here, right? And here I have my connection options. So profiles are applied and inherit it. So I define it globally, I apply it to the peer group, and now my peer inherited de facto. I don't want this. For example, my dampening profile, I don't want that. I want another one. I can decouple the peer from the peer group at that level. So the notion here of the peer group is a little bit different than a Cisco, where for us it's more an administrative notion, and you can decouple certain parameter of your peer from the peer group at any point in time. Once again, the advanced button, and here we have some of the VFD functions hiding there for the advanced button. Then I don't know if I have more time, but that's pretty much what I wanted to cover with you. I hope you found this interesting. I hope that matched the criteria of the user group that you belong. And
it most definitely did, Patrick, no question. Looks like we are going to be wrapping up with Patrick here. If anyone has any last minute questions, go ahead and slip them in. There was one more question from Adrian. You went through the LRE to ARE process and had issues in the network after the reboot. To revert, can you just deselect the advanced routing option, commit and reboot?
Yes, and you will be reverted to your last saved configuration.
Okay. And then now on a traditional VR, all routing protocols run on the same daemon, or as the LRs, every routing protocol can run on a separate daemon process?
Yes. So in the legacy routing engine, it's a single loop with all the protocol, as a point of insertion inside that loop. So, for example, if you have BGP enable, it will go through BGP, nothing to do, it come back to the loop, right? So there's no difficult to do multi-threading with this or multitasking with this. So if you apply this to a modern processor, we can do multi-threading and multitasking. So in an LR, each routing protocol is a specific daemon, right? You have a BGP daemon, you have an OSPF v2 daemon, you have an OSPF v3 daemon, etc., etc.
Fantastic. Again, everyone, I just went ahead and threw the link in again for live community. If you do think of any questions later, have those icebox questions hit your brain tonight after dinner or something, you can go ahead and post your questions to the live community, and either Patrick or some peers or anyone will be able to try and help you with your issues and whatnot. So with that, then, I would like to thank Patrick very much for your time today. I really appreciate it. I know, everyone, we went a little bit long on time, but I think the material was absolutely fantastic. And Patrick, thank you very much for taking the time to speak with us today.
My pleasure.
And I will go ahead and let you go.